Okay, so we're going to solve quadratic inequalities. Today we're going to do it by graphing. All right, when you look at a quadratic, okay, we've done how to solve ones that have equals, but what happens when you have a quadratic and it's something like 3x squared plus 6x is greater than 7? Hold on, I'm hearing myself talk. Okay, so inequalities. When you're looking at this equation right here, this part that I've got shaded. Okay, here's an inequality, and it says here's your quadratic, and it says it's greater than 0. So a quadratic that's greater than 0 is just the parts of the quadratic that are above the x-axis. Okay, so when I see this, I'm looking at parts of where are the y values above the x-axis. So this is y values above the x-axis. Okay, because of the greater than or equal to. So the equal to just means that the y values could be on the x-axis. Okay, now, if you have less than symbols, then you're looking for the parts of the graph that are below the x-axis. So the y values that are below the x-axis. All right, now the values where it crosses the x-axis we call critical points or critical values. So that x-coordinate is some x-coordinate b. And the x-coordinate over here is another x-coordinate, and we'll just call it a. All right, so the x values that create positive y values are all the x values that are outside the two critical values. Okay, so that's what this is telling you right here. X is greater than b. Any x to the right of b is going to have a positive y value. And any x to the left of a is going to have a positive y value associated with it. So the intervals where the y values are positive, you use these critical values to define them. Right? So let's take a look at it. Let me show you an example. So go to greater right here. Okay, go to number 4 on the second page. Okay. So what I'm going to do is, this has got a greater than symbol in it. First thing I'm going to do is move the 4 to the other side so that this thing has a 0. So I'm going to add 4 to both sides. Greater than 0. Okay. Now, the two critical points are 1 and 4. So I'm going to put one critical point there, and another critical point there. Now, all of the y values are any x value that is to the right of 4 is going to have a positive y value, because this is where the graph is positive. I'm highlighting it in yellow. And this is the other place where the graph is positive. When I say the graph is positive, that means the y values are above the x-axis. They're greater than 0. So any x value to the right of 4, I would write like this. X is greater than 4. If I was writing that in interval notation, I would go parentheses 4, infinity. Okay, the other place where the y values are positive, so you could pick y values that are smaller than 1. So I could say x is less than 1. And the way I write that is negative infinity up to, but not including 1. Now the word or, we use the upside down or the letter U. When we see that, that just means or. The way that I would represent this on a number line is right above the 4. Since it doesn't have an equal sign, I draw an open circle and then an arrow going to the right. And to represent all the numbers smaller but not including 1, I draw an open circle and all the arrows to the left. So any y value, any x value in either one of these intervals would have a y value that's positive. So remember this part right here. This is an interval. Yes. No. Okay, so this is called an interval. Any x value from either interval will have a positive y value. And the intervals I highlighted in green. That's interval notation. Okay, can I move that? Yes? Marcos? Okay. All right, so back over here, if you're looking for, here's a kind of a general rule that you can use. If the graph is opening up and you're looking for the positive, where it's positive, you're going to look outside the critical points. So our interval, the intervals that we're looking for on here, or the intervals that satisfy this, are outside the critical point. The critical point. So intervals are outside both A and B, or I'm just going to write are outside the critical values. All right, when the graph opens up and you're looking for where it's below the x-axis, the intervals are between. There's only one, too. This one's going to be plural. Here, there's just one interval, and it's between the critical values. And we could just write x-intercepts. That's probably better. Instead of critical values, just say x-intercepts. And it's just the reverse of this when the graph opens down. Okay, so this is, we did graph opens up. And over here, when the graph opens down, if the greater than is going to be between the x-intercepts, and the less than is going to be outside the x-intercepts. So this is going to be interval. Interval is between x-intercepts. Okay, and then here it's outside the x-intercepts. And there's two intervals. This one is interval. Now we're going to be tying this in with the discriminant, because where the discriminant's positive or above the x-axis, it means something. When the discriminant's below the x-axis, it tells you something else. So these sign diagrams that we're going to make when we start doing this algebraically are something that you use all the time. If you go on to the next level of this class, and that's with the calculus part in it, you're going to be using lots of sign diagrams. All right, so solve the quadratic inequality by graphing. So just to save time, I already graphed them. What? Oh, no, why didn't you guys say something? Okay, hold on. Okay, Sam, say hello so I can see how loud it is. Sam? Okay, look, say count to 5. Yes. Okay, I'm just trying to turn the volume up so I can hear you guys. So you guys can't see my screen. Well, were you going to say something? You did? Did you guys hear her? Okay, guys, I can never see the chat. What I should do is have one of you guys in here like monitor the chat. What's that? I was staring at the camera? Oh. You're on there now. What the heck? Oh, to monitor the chat. Jaden. You can blur your background now on Google Classroom. You can also put in like green screen stuff, which I love. I like the green screen. Can't have to admit. I like the green screen. Okay. Yeah, so like if people are in the background or if there's being a crime committed in your house and you don't want anybody to see. Yeah. Well, not necessarily you. Okay. You're there. Okay, what was I doing? Okay, now we're good, right, guys? At home? Sam? Good to go, Sam? See the screen? Then the other cam is my class cam, 24-hour class cam that I run. Because the other part of the world, so when the other part of the world is open or awake, they can see what's going on in my classroom. It's just dark in here. They're like, not, yeah. No. I do have a cot behind that, behind my, I do. I got a cot and a pillow behind the screen that I use before football games to take naps. Oh yeah, I'd love. Okay, here we go. All right, so now we've got a less than that opens up. A less than that opens up, we're going to be looking between the x-intercepts. Okay, so a less than that opens up, go between the x-intercepts. So this graph is going to be less than 0 between -9 and -3. So less than -3, but greater than -9. Because this is where the graph is negative. Okay, as an interval, that would be parentheses -9, -3. And on a number line, that would be open circle, and then I would shade everything in between them. So this was between x-intercepts. All right, the next one opens up and is a greater than or equal to. So I go up to my little cheat sheet here. Intervals are going to be outside the x-intercepts. All right, so where this thing is positive is outside of the two x-intercepts. So that's when I'm going to have my either or. Now, the only thing that's different now, though, is instead of having a parenthesis, it's a bracket. Okay, so this would be x is greater than or equal to 3. This guy would be x is less than or equal to -5. All right, how would you write those as intervals? Marcos, how would I write this as an interval? X is greater than 3, greater than or equal to. Intersection or union, I'm sorry.
Then a bracket, comma, or 3, comma.
Yep, there you go. And then on my number line, I'd have dots instead of circles, because those values are included in the intervals. Okay, now what I forgot to do here, guys, if you're graphing this, when you put this into your calculator, you got to have it so that it's 0 here. So I would move the 15 over by subtracting it, and then I would solve this inequality. So right now, we're just doing it by looking at the graph. Then we're going to do it without looking at the graph. All right, so this one, we got to move the 8 over. Less than or equal to 0. And Rachel, are we going to find the negative part of this graph between the x-intercepts or outside? So we're looking for the part of this graph where the y values are negative. Okay, so between the two x-intercepts. This part that I'm coloring in red are all negative y values. So if you are a negative y value, your x-coordinate is going to be between those two numbers and included. So that's how we write between. Okay, as an interval. Okay, Mackenzie, what would that be as an interval? They are included. Well, it's between 4 and 1. Yeah. Okay, dot, shaded. Critical point is a -4 and a 1. So this one was outside x-intercepts. Yes, ma'am.
So, know that you're looking for the constant.
You know you're looking for the negatives because of that. So when I see this means less than 0. Less than 0. And if it's this, that would be greater than 0. So that's how you tell. Okay. When you're reading an inequality, guys, you read it from left to right, like you read a sentence. All right. Okay, Eslin, how about number 5? It's opens down and it's a less than 0. Where are we going to find? Are we looking for the part of the graph that's negative or positive? Pardon me? Negative, yep. And where are we going to find that? Outside the x-intercepts or between them? Okay, pardon me? Between, all right. So I'm going to shade in between the x-intercepts. You go. Oh, there it is. All right. So the part that is negative is going to be, I'll just color it in red here. So do you see how those, it's kind of small, how those two parts are outside the two x-intercepts? So that's what we're looking for here. The part of the interval that is outside the two x-intercepts. All right, so outside the x-intercepts, outside, right? And then, so we're going to be, that would be from x greater than or equal to 1, which would be bracket 1 comma infinity, or, no, because that's to the right of the 1, and then x is less than or equal to -2, which would be negative infinity, -2 bracket, and then the union between those two. The union just stands for the word or. You see that U, it stands for or, either or. All right, and now I'm going to have dot, dot, and arrow, arrow, and my x-intercepts right here. Okay, Dylan, last one. Where are we going to find on number 6? Where are we going to find losing my whole darn picture. There it is. Okay. Graph opens down and we're looking for greater than. Say it again.
Find what we're looking for.
Correct. So would it be between the x-intercepts or outside of them? It'd be between them. This little piece that sticks above the x-axis. Okay. So between those would be all the numbers between and including 5 and 7. Yep. Bracket, bracket, 5, 7, solid dot, solid dot. All right, now when you do this on your calculator for the assignment, so we'll stop the notes here and use this discriminative tomorrow. But I wanted to show you on the assignments due Thursday, but some of it, if you wanted to start it early, you could. You should now be able to do question 2. So you got A and B on question 2. All right, now to do this on your calculator, all you got to do is just find the x-intercepts. So we'll do an example here. We'll do 2C. Right, so I got 8x squared minus 3x is less than 9. Okay, so the first thing I do is I move that 9 to the other side. That's what's included right here. Step 1 says rearrange the inequality so one side is 0. Did it. Graph the corresponding function. Identify the critical values, okay, which are the x-intercepts. Ready? So you're going to put that into your calculator. I'm going to move the 9 over. And this is what I graph on my calculator. Now, before we go any further, this graph opens up and it's a less than. Where are we going to find the critical points? Opens up and is a less than. Yep, between the x-intercepts. So that's where we're going to look once we graph this guy. Okay, so we'll look, our interval is going to be between whatever we get as the x-intercepts. Okay, so I'm going to write here between x-intercepts. So this is what you would show like on your work for these. Yeah, we're going to graph them, but all you got to do is just get the x-intercepts. So you really, you can, but when we test on this, it's all going to be on the TI-84. So you want to, even though the TI-84 takes longer, it's what you're going to have to need to know how to use. Like when you leave here and you go to college, you're not going to be able to use Desmos. It's going to be a TI-84, believe it or not. TI-84s, you can program them. You can turn them into little Macintoshes. You can, it's pretty amazing. Or, I mean, an Apple computer. You can put games on them, and it plays just like a video game, except, not super great graphics. You can program, the way that they're built, you can program them with all sorts of different languages, computer languages. Okay, so we're going to put that guy in here. So we got y equals 8x squared minus 3x minus 9. Okay, so 8x squared minus 3x minus 9. Okay, and then I graph that. I'm just going to put on a regular graph. So like zoom 6, puts it on a standard 10 by 10. And there it is. Okay, then to find the x-intercepts, you go second calc, and you choose 2, 0. Then you got to go through the whole right bound, left bound. So the left bound means before the x-intercept. As you move from left to right, enter. The right bound is after. And guys, you can skip the guess. Just when it says guess, just hit enter. Okay, there's our 0. So if I round that to 3 sig figs, the 6 would make the 9 a 10, and that would make this a 9. So it would be negative 0.890. Okay, so let's see. It's between the two x-intercepts. So it's going to be x is greater than 0.890. 0.890, and then do the other x-intercept. Second calc. Yeah, I got too many things. Bound, enter. Right bound, enter. Skip, enter. 1.26. That's my other one. And then you can draw your frozen, right? Control V, paste. I wanted to paste the picture, but okay. What was the decimal that we got on the right side? Okay, 1.26. Then I'd write that as an interval as bracket. This was negative, positive. And then if I did it as a number line, it would be circle, circle, and in between. Okay, guys, so we'll stop there for today, and then we'll continue tomorrow with how does this relate to the discriminant. So no homework yet. So you folks at home, on Google Classroom, if you just are at home and you were here yesterday, then you should have the packet.
I thought this was new.
Oh, it was a new packet. That's right. You don't have the packet. Now, you folks at home, if you want to get packets, you don't have a printer, you could ask one of the fine people that are still here to bring you one. I'm sure they'd be more than willing to. Okay, so I'll see you guys tomorrow. See you, Sam. Carmela. So if any of you end up being sent home, I'm not going to use the Meet links within the classes anymore. I have one size fits all Google Meet that is just open all day long. That's my class 24-hour class cam. That's like, oh my God, that's so cool. For you guys, big deal. But someone from mine is just like, this is so cool. Because, you never had it.
Where are you getting these things from? Most of my
doing?
involved in military power and assistance.
How are you doing?